My dear students, researchers, industry personnel and others, welcome to the course on phase transformations of materials. You know, phase transformation is ubiquitous in environment. In a hot summer day when you are thirsty, you will like to take ice cubes out of your deep freezer and add into water. So, immediately the ice cube will start dissolving or rather transforming from solid state to liquid state. So, in every parts of life we see variety of phase transformations. In material science particularly, phase transformations are important because they play very important role in dictating the material properties. To give an example of steels, steel metallurgy, especially the physical metal of steel, basically concentrated on the phase transformations. Similarly, non-ferrous materials like aluminum alloys, copper alloys and so on. In fact, in all these alloys, the important thing which we study as a part of our curriculum is how to control the phase transformations. Just to give an example, in steels, if I take in plain carbon steel, very small amount of carbon, let us say about 0.6, 0.7% weight % carbon, we can have different microstructures based on how you cool the steel. If you cool very slowly, you will have certain kind of microstructure consisting of certain kind of phases. If you cool it very fast, just by putting the steel sample, hot steel sample directly from the furnace to the cold water, then you will have another kind of microstructure. On the other hand, if you cool it intermediately and keep it long, you will have a third kind of microstructures. So, therefore, by simply changing the processing conditions of steel, we can generate different microstructures by transforming the parent phase to some other product phases, and that is the basis of generating different microstructure in steels. Similarly, for the cast iron, aluminum alloys, which is workhorse of the aerospace industry, the widely used because of the precipitation hardening. Precipitates of very nano size or small size can be formed by aging aluminum copper alloys or aluminum copper silicon alloys. So, therefore, all these phase transformations can be basically controlled to generate different kind of microstructure, leading to a variety of physical, mechanical, electronic or other properties. In fact, the magnetic material also we can actually control phase transformations to get different kinds of magnetic properties, soft or hard. So, in a nutshell, I could say that in metallic materials phase transformations plays very important role, but I will be not doing justice if I say similar thing does not happen in ceramics. In many of the ceramics, especially in zirconium oxide or even many other oxides or carbides, phase transformations is also very pertinent and their control the mechanical and physical properties. Zirconium oxide can be transformed to separate different phases, leading to what is known as popularly transformation toughening. So, in a nutshell, again I would like to reiterate that phase transformations in the material science play a stellar role in controlling microstructure. So, thus it is important for all of us material scientists across the globe to understand the phase transformations, their genesis, their scientific aspects of the phase transformation, to correlate it to the industry, because finally the materials are produced in mass scale in the industry for applications. So, in this course I am going to talk from the very basics of phase transformations and utilize these basic concepts like phase diagrams, thermodynamics, diffusion, different aspects of kinetics at the beginning. Then slowly I will move into different kinds of liquid to solid to solid phase transformations present in the materials. Obviously, as I told you in this introductory lecture, that steels will be major part of the discussion in this course. So finally, I welcome you all, and let me iterate that this course will be very effective for you if you have some basic understanding of phase diagrams, diffusion, as well as material science, basic material science like crystal structure, phases, microstructure. If you do not have, you do not be scared, because in the whole process I will be giving you reference of different books, write-ups, or even internet sites where basic information will be available. So therefore, in a very short way, I would like to tell you that you will enjoy this course during the whole semester, learning different basic aspects of the phase transformations, and I do hope, again I am going to reiterate, I do hope at the end of the course, if not a master, but you will have a very basic idea of the different kinds of phase transformation we observe in different material systems, and you will be able to garner sufficient knowledge to move forward, whether you are in academics or research laboratories or in industry. Thank you all.